Excuse me. And don't worry, I tried to keep your guys' faces out of the video as much as possible.
I'm good on that one.
Alright guys, so as you know, I'm Mr. Fox, and I'm here doing some of my student teaching stuff, taking a video for my class. So we're just going to go through the notes like you normally would or whatever, and you guys don't have to do anything different, it's all on me. Alright, so we're talking about changes in matter. Physical change is one that affects one or more physical properties. So you guys watched that video yesterday. Can somebody remember something that is a physical change? One thing that indicates a physical change or anything about it?
Cutting the cloth.
Cutting the cloth. That's a physical change. Why is this a physical change? Because it is still the same material, right? We're just changing the shape or size of it. So this will not change the identity of a substance. It's still a cloth whenever we cut it, but it's not, changing any sort of chemical part of it. When ice melts to form water, it's still water because it can still be refrozen again. Nothing's changing about the water, just the way it is at the time. So some more examples of physical change. Change in state, that's like liquid solid. Change in shape, that's like cutting the cloth. Change in size, also cutting it, whatever. Any way you can think of doing it. Crumpling up a piece of paper can change the size of something. And dissolving, like sugar or salt into water. Even though it might be harder to get out and see that it's still the same, it still is. Mixtures can be separated by physical changes, and there's different levels of mixtures and stuff like that we'll get to here probably eventually. But some more ideas along with those mixtures. Boiling salt water can separate the components. If you boil all the water out, you'll be left with the salt behind to kind of show that it's still the same thing. Sifting a mixture of sand and gravel can separate them. Have any of you gone to the beach and had one of the sifter things to scoop up sand and shells in? You get all the sand out. Kind of the same way you can think of a mixture. So, chemical changes are different because they change what the material is or what it, is going to be. So, a chemical change happens when the chemical makeup of one or more substances is changed. This will turn the substance into something completely different. So there you can see something burning. The ashes of the paper are completely different than the paper was originally. You can't write on it, right? Firework, it used to be just some powder packed inside of a little container, and now it's that. A lot different. So batteries dying, that's a chemical change. The chemicals within them are being used. Leaves changing color, oxygen in your body, caramelizing sugar. Actually, the leaves changing color is an interesting one because whenever something happens to something and its color changes, a lot of time that indicates a chemical change is happening. So some compounds can be broken down through chemical changes. What do you think dropping Mentos into Diet Coke is? Is that a physical change or a chemical change?
Chemical.
Chemical, that's right. That's one thing that does, as you know, is produce a lot of gas. And whenever something produces gas, that is another clue that there's a chemical change. Anything else on this slide? All right, let's try to see if we can figure out some physical and chemical changes here.
So they all have this on their screen too.
All right, you guys all have that up? Would you mind getting that up? We can take a second, it's all right.
So this is what they're answering. Answering as you're going through. So this is what they're answering. 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 So this is Just a minute. Just a minute. Come in, just a minute.
While we're waiting on everyone to get set up, anybody have any like questions about physical or chemical changes or any ideas?
No.
Nothing? Not yet anyway?
No, but I'm eating a,
Something that was baked this morning?
yeah.
And? You think that's a physical or chemical change? Baking a biscuit?
Chemical change.
You got it.
This one.
Yeah.
Oh, you both have scratched throats.
There you go, that's where we are here, see?
Mr. Fox,
Yeah.
what is
So you can see?
Coke made out of? Is it chemical or physical?
So, I guess when Coke is being made, there's probably some chemical changes, but anything that just exists, let's say these cards or anything, it's not that it's a physical or chemical thing, it's both. It has the potential to do, but if it were to
Yeah.
be changed somehow, that's what we're talking about.
Yeah,
How we
but
change things.
like Mrs. Combs shakes.
Yeah,
That's physical.
right. You get, I think you're good.
Yeah.
All right, most people have it up at least? Cool. All right, we'll get going, and I'm going to maybe call on people. We'll see how that goes. If you don't know it, it's okay, just say you don't know, we can move on. But give it a try. All right, number one, it says using a mortar and pestle to grind up a substance into a fine powder. This is used a lot in like cooking and stuff like that. So if you gotta grind up like some nutmeg or something like that. Physical or chemical change?
Chemical change? Physical?
Physical change, great. It's physical because we're changing the shape and size of it. Hey, it's all right. There's nothing wrong with getting it wrong, guys. You guys are just learning this stuff, so don't be afraid to get the answer wrong. It's not a big deal. Yeah, physical change, changing the shape and size of something. All right. Second one, you watch solid carbon dioxide, that's like dry ice, change into a gaseous form. So if any of you have seen dry ice, you've probably seen the steam that's around it. Is that a physical or chemical change? This one's kind of tricky too.
Chemical.
Chemical change, that's what you would think whenever you'd see the production of gas. But it's actually a physical change because it's just changing the state of matter. It's going from solid to a gas. Theoretically, it could go back to a solid. That one is a little tricky. That's all right, good try. I knew that one was going to be tricky. I'll give you another one so you can redeem yourself. All right, number 3, an electrical current causes water to be transformed into hydrogen and oxygen gases.
Me?
Yeah.
Chemical.
Chemical changes, that's right. It's taking out, it used to be H2O, and now it's separating those chemicals, so it's a chemical change. Good job. Number 4, you mix flour, water, and sugar to make cookie dough.
Physical.
Physical, that's actually right, yeah. So, now whenever you mix them, you're just putting all the different parts, and you could theoretically separate them back out. It would be really hard, if not impossible, to do in that state, but they're still not really changed yet. What do you think after you bake them?
That would be a chemical.
Yeah, that's right. Very good. Once we bake them, that's when the chemical changes happen. You can smell the cookies, baking in the oven. That's a good indication. All right, number 5. You add iodine to cornstarch solution and produce a new blue substance. What do you think? It's okay. So here's the real kicker here, okay? You produce a new blue substance. If a new substance is being produced, what do you think? Do you want help her? Chemical change. Why do you think that?
Chemicals.
Because we're producing a new substance. Very good. Yeah, that's a chemical change. All right. Number 6, you cut an apple into 12 slices with a knife. Landon, what do you think? Is it physical or chemical? Physical, that's right. Good job. So we're cutting the apple into slices. It's still an apple, just in slices now. All right, number 7, it says your sliced apple from lunch has turned brown.
Ew.
Here's your chance for redemption. What do you think? Now that the sliced apple has turned brown, do you think that's a physical or a chemical change? Chemical, that's right. Good. Because changing color, it's not going to be a fresh apple ever again, no matter what you do to it. All right, 8. You make a homemade volcano by mixing baking soda and vinegar, and it foams up and explodes. What do you think, Ethan? You want me to repeat it? All right, if you make a homemade volcano by mixing baking soda and vinegar, do you think that's a physical or a chemical change? Chemical change, that's right. Good job, Ethan and Noah. You guys got it. So, yeah, you mix up the baking soda and vinegar, and it produces a whole bunch of gases and liquids going all over the place. All right, number 9 says you mix food coloring into the icing for your friend's birthday cake to make it blue.
Chemical.
Chemical.
May
I don't think so in this case.
I said it too fast. It's a physical.
It is physical. A lot of times changing color can be chemical. You're right about that. But in this case, we're using a dye to mix into it. And anytime we hear the word mixture or mixing something together,
It's a physical.
that's kind of an indication that it's a physical. That's right. All right, number 10. While you are filling your car with gasoline, I don't think any of you drive, do you? Not yet?
I mean, I drive, but
Noah
not.
drives. Noah's
Thinks
going
he
to
does.
Mexico.
Going to Mexico, that's right.
Driving that much.
By filling your car with gasoline, a small amount spills but soon disappears. I'll give somebody a chance to raise their hand if you think you know this. Ethan, what do you think? Want me to read it one more time for you? All right. While you're filling your car with gasoline, a small amount spills, but it soon disappears.
Don't knock that on the floor.
I think that's a physical or a chemical change. That is a physical change, that's right. It's changing its state of matter from a liquid gasoline and it's evaporating into gasoline, but it could theoretically, be captured and condensed back into the liquid again. All right, 11, after you drive your car around town, less gasoline remains in the tank. Where'd the gas go is the question. What's happened to it? Take your time.
No, I was thinking Mr. Fox. I think it was going to the heart.
The heart of the car.
Yeah.
That's right.
Physical?
Take what you get.
Oh, I'm sorry. Good try. It's a chemical change because it gets pulled into the engine. And what happens to the gasoline in the engine? Anybody know what happens to the gasoline in the engine?
It burns off.
It burns.
It burns up. And whenever we're burning this gasoline or igniting it, we're unlocking all the chemical, energy that it has inside of it. That's a chemical change happening to it. It comes out of our exhaust pipe as fumes and stuff like that. Here, run that back. I'm going to give you another chance here, okay? Number 12. After swimming in the ocean and resting on the beach, you are no longer wet, but your skin has a salty film on it. Physical, that's right. You got salt water on you and all the water evaporated off because it's a hot summer day. We can all imagine that today, right?
Oh yeah, I would like to go swimming.
All right, 13.
Down one. There you go.
All right. After stirring some sugar into your iced tea, the sugar disappears, but the tea tastes sweet. Ethan? That's right, physical change. We're mixing the sugar in. It's dissolving in, but it's still its own separate entities. We could theoretically boil it until all the liquid evaporated out and get our sugar back if we wanted to. All right, 14, you dissolve an Alka-Seltzer tablet into water and it bubbles and fizzes.
Chemical change.
Chemical change, I think. That seems right. I guess I don't know the science behind Alka-Seltzer, but when we're seeing gases forming and stuff like that,
We'll actually do this in a lab and it heats the water up too.
does it? Okay. Another indication that it's chemicals when we're seeing heat produced from it. Didn't know that. 15. A plant uses sunlight to make energy by photosynthesis. Give you another chance. Think physical or chemical for a plant using sunlight to make energy. Why do you think it's physical? It's okay.
I don't know, because
Is the plant's growing?
yeah.
That's the right piece of evidence, but the wrong answer. So because the plant's growing, because the actual like thing is, you know, permanently happening to this, that means it's a chemical change, okay? It's, we could write this out as a chemical formula and reaction actually for the sunlight going into the plant with carbon dioxide and water, it produces oxygen and then the sugar for itself to grow and eat. All right, number 16, your bicycle has rusted in the rain.
Chemical.
Chemical, yeah, for sure. Rust is a chemical reaction. It's oxygen reacting with the metal. All right, number 17, you chop wood for a bonfire. Chop the wood. We're not catching it on fire yet. Physical change. And then if we did catch the wood on fire, Noah, what do you think? Hey, Noah, if we caught wood on fire, do you think that's a physical or a chemical change? Chemical change, that's right. It can't be undone. And just chopping the wood is just a physical change. Perfect. Good job, guys. All right, 18, giant salt crystals have formed in a cave. That one's also kind of tough. Anybody brave enough to try it?
What?
What?
Let's go
No.
up front here.
Chemical.
Chemical.
My body be like bigger.
I don't think so. No, we're just changing the size of the crystals of the salt. They're forming together more and more. You're getting all the tough ones today. I'm sorry.
So the salt's already in the cave, right? And the water's already in the cave. Think about salt and water like mixture in a pitcher, right? It's
Yeah.
still just salt and water.
Right. Yeah.
That'd be yucky.
I guess depending on how they formed, if somehow maybe they formed from a
Mr.
chemical
Fox,
reaction, you could argue
Mr. Fox, are you brave to eat the salt crystals?
that. Don't eat salt you find in caves. That's gross. Because there's lots of different salt. The salt we use at lunch is sodium chloride, but we
Yeah.
don't know if that's like
Just one.
calcium fluoride or something like that. It could be
Yeah.
super deadly to humans. There's a lot of different kinds of salt. So, yeah, don't eat random salt you find. Just stick with the stuff in the cafeteria. All right, 19. Mushrooms decompose the soil beneath them. What do you think?
A physical change?
No, there's an actual chemical change happening whenever you see mushrooms
Okay, okay.
dissolving. Plant growth and like mushrooms and all these things, they're growing. They're using nutrients, which is like, you know, the chemicals inside of things. So anytime you see something growing from it or something using nutrients or food, that's going to be a chemical change, all right? When we eat things, okay, that's a chemical change. We are taking the chemicals out of the food. All right, 20. You activate glow sticks for the party. Yes,
Chemical.
chemical for sure. Yeah, we are breaking the little bits and getting it all. And whenever the different parts of it hit each other, we see the chemical reaction as glowing lights. Yep, definitely showing it. All right,
Go back.
few more. 21. You cut your hair.
Physical.
Physical. That's right. If you burnt your hair on accident over
Like-
the fire cooking, then
like
that's
Michael
chemical
Jackson.
change.
I had a good one, like Michael Jackson.
Great snack.
All right. 22. A baseball breaks a window. Ethan? A physical change. That's right. Good. The window is shattered. We could, with a lot of patience, maybe glue it back together or something. It's still pieces of glass. You know, it doesn't change to a different thing when it hits the ground. All right. Man, I did that once to my neighbor, broke his window with a baseball, and I got in a lot of
I
trouble.
broke our neighbor's window with a snowball.
Did you get in a lot of trouble for it?
No.
Lucky you. Alright, 23. You
Good
make
enough.
popcorn for a sleepover.
Chemical.
Why?
I don't know, because the popcorn is changing from kernel to popcorn.
Yeah.
Popping.
Yeah, I think that's right. Yeah. We're cooking things. Anytime. Can you smell the popcorn being popped?
Yeah.
Yeah. If you can smell it, then that's a good indication. All right. 24. Fireworks explode at a New Year's celebration. Noah, if fireworks are exploding, is that a physical or a chemical change? Chemical change. That's right. Nice.
There you are.
You said chemical, right?
Yes.
Yeah, I thought so. Yep. Anytime we're seeing big explosions like that, then, yeah, we're definitely seeing a chemical change. What do we have here?
So they're gonna read this and then highlight the parts that are physical and chemical changes. They're gonna do that by themselves, so you don't
Sounds good.
Let's discuss it.
Alright, so you guys can just, I don't know, how much time do we have left? 10 minutes? Yeah, you guys can get started on that. We'll go around. Oh, yeah. Is it seriously? That's hit control and then the button right by the backspace. No, well, it was thinking about working out.
Do the minus and then it'll make it bigger. It's opposite on Google Slides for some reason.
It's not on mine.
Well, you just have to deal with it then.
That's what that- the control minus.
Zoom minus.
See if you can get it.
I can't see that.
Do you mind if I mess with that for a second? Try and get it working?
I didn't wear my glasses. Where are they?
Control. Whoa. That's control minus.
What? Yeah, I'm half body.
Um,
I mean, you never know, Mr. Fox. You get it?
I think about Florida. Look,
Okay.
I'm gonna find the sort on. I can't even read that. I think that's
If you make it, if you hit control minus as many times as you can, that's legible, I think.
Okay, so if you click on science, there's one, I know what physical and chemical changes.
Yeah, we might have to like print that or something.
Yeah, mine's a print you off.
Yeah.
Yeah, it's done.
Maybe for tomorrow or whatever, depending on if we have school.
There's a little magnifying glass on your page. If you hit that, it'll bring it like to where you can actually see.
I have to read this whole thing.
why is this so small?
And we water.
Oh, nice. Okay. Did you figure out how to do that? Good. Once you're on the spot. People the wrong way.
Yeah, so here we're gonna.
These are my glasses.
There we go.
I have to wear permanently.
Where did yours go?
What?
Just made it real small.
Oh. I see it. Let me fix it. That's probably my fault.
Everything's your fault.
Next week.
Well, that's probably not true.
It's still recording.
should do it.
That's okay, I know.
Oh. At least you get a little talking in the video.
That's, they just wanna see, you know, me teaching and
Yeah.
helping and whatever, so that's what we're doing.
3, 8,
Gotta wash my glasses. Gotta wash my glasses.
Did you get it to where, okay, cool.
6,
You guys got yours?
6, 5, 8, 2.
Hey, perfect.
There you go. Okay, science, look for science.
I'm gonna guess we'll go over this maybe tomorrow if we're here.
He's on. You did good. What is it? Is it? Let me look at this real quick.